everyone, I'm Mark, and welcome to the second series of the video. For this series, I have decided to do polynomial units because I decided to do polynomial unit first because I think it was a little level up after the quadratic function unit, and I think that doing it earlier can help me to lay a stronger foundation. So let's maybe when I'm really doing the quadratic unit, it will be much easier, a much simpler process when in terms of calculation. So let's get straight to it. There are 5 small subunits I'm going to talk about. So let's go. So how do we, first of all, let's get to the foundation first of how do we add or subtract two polynomials. To add and subtract, we combine like terms, which means that the same term of x will combine together or will subtract together. So for example, if the p function is x to the power of 3 minus 2 times x squared plus 3x minus 5, and qx is 2 times x 2x cubic plus x squared minus 11. So when you are adding px and qx together, you're combining the term. You will combine the terms with x to the power of 3. So for px, the coefficient in front of x cubic is 1. For qx, the coefficient in front of x3 is 2. 1 plus 2 is 3, so the first term is 3. Same for x squared. The coefficient for px is minus 2. The coefficient for qx is 1. Minus 2 plus 1 is minus 1. And now look at the third term, the x term. The coefficient of px for x term is 3. For qx, there is no x term in the equation, which means that the coefficient is 0. 3 plus 0, the answer is 3. And for the last constant term, the px is minus 5, qx is minus 11, minus 5 plus minus 11 is minus 16. And that's just the most simple one. And the addition and the subtractions are the most simple one. And now there are also other more complex ones as well, such as when you see the multiplication of polynomials. When multiplying, you multiply each term of the first polynomials with the second one, and then connect the like terms together. For example, this example, px equals to x cubic minus 2x plus 4, qx equals to 2x squared plus 3x minus 5. And how do we multiply them together? First of all, you create two parentheses to separate them together, and then you take out each of the single term in the first parentheses, and then times with the second, and then times the one with the second. For example, for this one, px times qx equals to x to the cubic times every single term in this parentheses, which means x cubic times 2x squared, x cubic times 3 squared, x cubic times 3x, and then x cubic times minus 5. But there are also two more terms. The second term is minus 2x, so you single minus 2x out of the equation, and then you time with q out of the px equation, and then you time with qx. So minus 2x will first times with 2x squared, then minus 2x will times with plus 3x, and then minus 2x will times with minus 5. And last term is 4, so 4 will first time with 2x squared, then 4 will then times with 3x, and then 4 will times with minus 5. After writing everything together, the like terms are combined, and then the like terms are combined and subtracted as well, you see here. So the final equation is 2x to the power 5 plus 3x to the power 4 minus 9 to the x cubic plus 2 times x squared plus 22x minus 20. So now let's look at the division of polynomials. For linear, so first of all, let's let's look at this equation mostly for IGCSE 0606. Equation will mainly come up like as a cubic for the highest term. So it is very important to understand the whole division process before we continue. So after division, it should look like this. There is going to be a divisor. There's going to be a quotient, the obtained quotient, and there's going to be a single out remainder. And now let's look at the process. 2x3 plus 7x squared plus 10x plus 15. Now given the divisor x plus 2, so divide everything by x plus 2. And now let's undergo the division process. To obtain as highest term 2x3 from the divisor, look at the term x. The final quotient for the highest power of x would have to be x squared to obtain x cubic. As the coefficient in front is 2, the 2 will be added in front as 2x squared times x as 2 cubic, 2x cubic. Even though there are a plus 2, a 2 for the constant as well. However, if there is no possibility for the quotient to have x cubic, as x times x cubic will be x to the x quartic, which will be higher than the original term. Now, let's use the quotient term to times the divisor term, and keep on with the division process. 2x squared times x times x is 2x cubic. 2x squared plus 2 times 2 is 4x squared. For division, to keep on dividing, 7 will minus 4, so as to obtain 3x squared, as the quotient will undergo as the two coefficients will subtract with each other. And let's keeping it going. 3 times 2 plus 10x. The term goes down below. The 10x drops below. The division continues as the equation hasn't finished yet. Look at the divisor, x plus 2. To obtain 3x2, the quotient will have to be 3x, as 3x times x is 3x squared. And that's the only way possible. So 3x will be times with x plus 2 to continue with the division process. 3x squared plus 3x times 2 is 6x, minus with each other is 4x now. So 4x, the 15 will drop, and 4x plus 15, and the division process will now continue. To obtain 4x, the quotient will have to be 4, because 4 times x is the only way you can obtain 4x. So then 4 times the divisor, with each term, 4 times x is 4x. 2 times 4 is 8, so it's 15. Minus 8, the remainder you get 7. So in the end, you will obtain 2x squared plus 3x plus 4 times with x plus 2 plus 7. But the equation is not finished, because what does this 7 of the remainder exactly mean? It doesn't mean the remainder is 7. It's actually not necessarily, because this remainder means that the remainder can no longer be dividing that term, because 7 is no longer enough to divide with x plus 2. So to put it in fraction form, 7 divided by x plus 2, the whole process cannot continue. So in this way, this is going to be the proper notation of the whole division of polynomials. As you can see right here, 2x squared plus 3x plus 4 put with 7 over x plus 2. And the algorithm is just as what I explained right here. But now let's look at a more complicated way for division by quadratics, which means that the divisor will be a quadratic function rather than a linear function. However, usually in this way, the whole process is the same. So for example, in this equation, x quadratic plus 4 times x cubic minus x plus 1 divided by x squared minus x plus 1. To obtain the highest power of x4, you need to divide. There is only x squared in the divisor, so the quotient will have to be x squared to obtain the highest power of x4. So to use it, so the first term of the quotient will be x squared. So using a highest power quotient to times each term in the divisor, x squared times x squared is x to the quadratic. X squared times with minus x is x cubic, and x squared times 1 is x squared. And undergoing subtraction for terms, 4x cubic minus negative x cubic is going to be 4x cubic plus x cubic, which will equal to 5x cubic. And as there is no previous term for x squared in the original function, it is assumed that which means that the coefficient in front of x squared is 0. It is more convenient. It is much more convenient for you to write a plus 0x squared in front inside the polynomial division process in order to save space for future divisions. So in this case, 0x squared minus positive x squared equals to minus x squared. There is 3 terms in the divisor. 1 more terms will be dropped below, which will mean the x term. The original function have a coefficient of -1, so it's 5x cubic minus x2 minus x squared minus x. And now using it to keep the division process, in order to obtain 5x cubic, you need to times with 5x for the quotient as is the only way to obtain 5x cubic. So 5x times with each of the term, 5x times x squared is 5x cubic, 5x times with minus x is minus 5x squared, 5x times 1 is plus 5x. And then undergoing subtraction, the first 2 terms will be 0, so no more x cubic terms will exist. Minus x squared minus 5x squared, which means that minus x squared will plus 5x squared, which means s will be 4x squared. Minus x will be subtracted with 5. We'll subtract 5x, so minus 1 subtract by 5 is minus 6. So it's 4x squared minus 6x. Now the constant term will keep dropping as the divisor has 3 terms. 4x squared minus 6x plus 1. Now to obtain 4x squared, the last term of the quotient will have to be 4, as 4 times x squared is going to be 4x squared. So 4x squared, 4 times with each of the term, 4 times with x squared is 4x squared, 4 times with minus x is minus 4x, 4 times with 1 is plus 4, subtract them. Minus 6 subtract with minus 4 is minus 2x, 1 subtract with minus 4 is minus 3x, is minus 3. As minus 2x is smaller than only has an x power of 1, but the divisor has an x power of 2 as the highest power, the division cannot continue. So the quotient is x squared plus 5x plus 4, and the remainder is minus 2x minus 3. However, if you want to write it in the proper notation, you need to write this as a fraction. So 2x minus 3 over the divisor x squared minus x plus 1. And that will be the final answer. And now let's look at the zeros, the roots and the factors. Learning this will be vital when you're learning futures theorems. So basically, a zero which means that the value of the x variable that will make the polynomial equals to 0, which means that any value of x that will make the y 0, making that straightforward. Roots are the solution of the given equation, which means the solution of x. And the roots and the zeros will be the intersection when drawing the graph. For example, when you are finding the zeros for this equation, x cubic minus 5x, you first find as x is a common term, you break the power down. So you single x out into x times x squared minus 5, and then that will equal to 0. Then to obtain the zeros, you keep breaking it down for x to the power of 1. So in this way, there's only going to be an addition or subtraction, and the result of x can be easily obtained. So breaking x squared minus 5 down as a squared minus b minus b squared will equal to a plus b times with a minus b. Breaking it down, 5 will equal to b squared, so b will be the root of 5. Then there will be a positive and a negative one. X plus x will be x squared, so it's x. So x times with x plus the root of 5 times with x minus the root of 5 will equal to 0. And the three zeros you obtained are minus root 5, 0, and the root of 5. Now let's do it in reverse, and then 0 is given. For instance, in this question, it asks you to find all the cubic polynomials with the zeros of 0.5 and minus 3 plus the root of 2 and minus 3 minus the root of 2. Do the factor theorem, which will give you a factor, but there is also an unknown term a inside the. For example, this is an a in the equation. For instance, in this question is given out that x plus 3 is a factor of x cubic plus a, the unknown term, times with x squared minus 7x plus 6. So since x plus 3 is a factor, which means that the final remainder is going to be 0. So in this case, x will have to. So in this case, to obtain ax squared, you need to times bx with the divisor to obtain for the ax squared. So to break it down, x cubic plus a times the x squared minus 7x plus 6. First of all, you single out the divisor, and then you match with the original function with the highest x power. So x times to obtain x cubic, x will have to times with x squared to obtain x cubic. To obtain ax squared, x will have to be times with the unknown bx to obtain ax squared, and then the value of the coefficient of b will add with 3x squared obtained over here to constitute the whole ax squared. For minus 7x, x times 2 is going to be 2x, which is going to be a part of this equation. However, at the same time, there is also a 3bx left. So 3bx plus is 2x. So 3b plus 2, the coefficients add together, and the answer is 5 minus 7. And here it goes for an inequality, 3b plus 2 equals to minus 7, as the question gives out the coefficient in front of x is minus 7. So in this case, b will be b is minus 3, and then at the same time, as there is also a 3x squared to constitute the coefficient of a in front of x squared in the original equation, a equals to b plus 3, and a will be 0. And then putting the value into the equation, breaking it down, the final product you get the final factors you get are going to be x plus 3 times with the quadratic function x squared minus 3x plus 2. Luckily, the quadratic function can keep breaking down, so there's no need for you to use the universal formula. So keep breaking that down. X squared minus 3x plus 2 equals to x minus 1 times with x minus 2. And then in the end, the two other factors are x minus 1 and x minus 2, and along with the factor of x plus 3. However, this is not what the question asked for. Now we have looked at the question that gives you out the constants, and now let's look at the new remainder theorem. So basically, remainder theorem is to input an x value inside the equation rather than undergoing the whole division process as a whole. For instance, over here, use the remainder theorem to find the remainder when, for this equation, x quartic minus 3 times with x cubic plus x minus 4. Use the remainder theorem as it's given by x as the divisor is x plus 2. It means that inputting the x value of minus 2 in this value, you are going to get the same value for manually dividing this equation with x plus 2 as it's the divisor. So inputting minus 2 inside the equation inside the x value, minus 2 quartic equals to 16, and then inputting the negative 2 inside the cubic function, inside x cubic, and then times 3 again. You get 24, and then inputting the negative 2 inside the x, which is minus 2 again, and then minus the constant term 4. And in the end, you get the remainder 34. Now let's look at this question again. This question gives you the remainder but have two unknown values in between. So this time using remainder theorem to solve it, we divide by x plus 3, the remainder is 11. So the remainder is negative 11. So in this case, x with a value of negative 3 is going to be input in the equation, which means that when inputting minus 3 when inputting the negative 3 in the equation, you'll get the remainder of negative 11. And when inputting the value of 2 inside this equation, you're going to get 9 as the final answer according to the remainder theorem. Therefore, you input the x value inside the polynomial, and then you will get two different inequalities, two different equations. Minus 3a plus b equals to 25, and 2a plus b is minus 15. Solving it simultaneously, you can add a minus sign in front of this equation. So the minus holding, so add two negative signs in the equation. So 3a minus b is going to be negative 25. 2a plus b is going to be minus 15. You add the first equation with the second equation, minus 15 minus negative 25. Subtract with 15 is minus 40. Negative b plus b is going to be no b anymore. And 3a plus 2a is going to be 5a. 5a is going to be negative 40. A is going to be negative 8. Negative 8. You input negative a into the equation. Negative a times 2 is negative 16. So b is going to equal 1. And now here goes the last theorem, the factor theorem, which is a bit of similar, but for the factor theorem, there is going to be no remainder, which means that when given x minus 2 as a factor of this one, the remainder is always going to be 0, rather than giving you another remainder value when using the remainder theorem. For example, looking at this question, x minus 2 is a factor of x cubic plus 3x squared minus 13x plus 6. When x equals to 2, input it in the equation, 2 cubic is 8 plus 3, and 3 times 2 squared minus 13, inputting 2 again, 13 times 2 is 26, and then plus the constant 6. In the end, you get the value of 0, which proves that x minus 2 is actually a factor of the original equation. Now, another question for factor theorem is to not let you determine, but to let you actually calculate the product. So in this question, it gives you that x minus 2 is a factor of x cubic plus kx squared minus 3x plus 6. So since x minus 2 is a factor, input in 2 in the equation, you will obtain 0 in the equation, as there is going to be no remainders left. Cubic is going to be 8 plus k times 2 squared minus 3, input in again, 3 times 2 is 6, and then plus 6 is going to be 0, as k terms is unknown. Now you get 8 plus 4k is 0, k is going to be negative 2. As you get as you obtain the value of k, then you input it back into the original equation. So the original equation is now x cubic minus 2x squared minus 3x plus 6. However, it is still unknown when breaking down the quadratic term of x, as there is two ways you can obtain the value of this. The coefficient of x squared can be obtained by timing bx with the x in divisor, and can be also obtained with timing the x squared with the minus 2 constant. So when you add them together, you will get minus 2 for the coefficient in front of x squared. So in this way, when you equate them together, you'll find b minus 2 is going to be x. b minus 2 is going to be negative 2, and b will equal to 0. You input the b value in, which will look like this now. X minus 2 times x squared minus 3. You break this down, you break the quadratic function down again into the x plus root of 3 times x minus the root of 3. Then you time with x minus 2, and by this you can find the zeros, and this is going to be the three linear factors for this equation. And that's it for this video. Make sure to leave out any questions for any confusions you may have. And this series over. Make sure to click like and subscribe if you like, and keep following the series along. And see you soon. And here are some practice questions you may do in your free time. And this series is now over. Thank you all, and see you in the next series.